Hi, in this video, we will see small DIY project, which will be giving brief introduction to Arduino IoT Cloud. We will make basic thermostat system using Arduino MKR Wi-Fi 1010 board and connect it to Arduino IoT Cloud for monitoring and controlling temperature. So, let's get started.
Hello all, welcome to Make to Explore channel. First of all, thank you to all our subscribers, viewers and supporters. We are going to use Arduino MKR Wi-Fi 1010 board in this tutorial. First, let's see the brief introduction to this development board. This hardware includes the feature which we have missed so much in our most popular Arduino board, the Arduino Uno. That is wireless connectivity. We know that, how it is very much needed in IoT projects design. So, this is MKR Wi-Fi 1010 board, which features ARM Cortex-M0 32-bit SAM-D21 processor, with the ECC508 crypto chip for security. And this U-Blox Nina W102 chip enables Bluetooth and Wi-Fi capability. Let's see more information about this development board on official website of Arduino. Here is the documentation of this board, which says, MKR Wi-Fi 1010 is the easiest entry point to basic IoT and Pico network application design. Whether you are looking at building a sensor network connected to your office or home router, or if you want to create a Bluetooth low-energy device sending data to a cell phone, the MKR Wi-Fi 1010 is your one-stop solution for many of the basic IoT application scenarios. Here you can explore Quick Start Guide, Pinout and Datasheet. In Setup Guide, when you click on this button, you will see the information about how to program this development board using different IDEs. Arduino has developed software tools that work for beginners, as well as for advanced users. You can select your preferred choice and continue with the Quick Start. Then next, in this Get Started guide, they have given the procedure of installing the SAM-D21 core for MKR boards. This is a step-by-step guide to install the core into an Arduino IDE. It is needed for programming the MKR family, like MKR 0 boards and Nano 33 IoT boards. Go through this guide to install this core into your Arduino IDE. All information is given with screenshots and elaborating tutorial. These steps are as shown here. First, downloading and installing. Then, installing the SAM-D core. Then next, selecting the port. And finally, how to uploading a simple example. We'll share this link in the description. Alright, then going back. Here you will find the detailed pinout diagram for MKR 1010 board. You can download it from here, and also this datasheet of this dev board for future reference. The MKR Wi-Fi 1010 is a great choice for any beginner, maker or professional, to get started with IoT, Internet of Things. These are the three main features which we have seen earlier. Down here, you will find the technical specifications for this Arduino board. Let's point out some important specs in brief. First and very important, operating voltage is 3.3 volts, not 5 volts. 8 digital I/O pins. 7 analog input pins. There is also 1 analog output pin. This MKR board supports communication protocols like UART, I2C and SPI. DC current per I/O pin is 7 mA, and so on. You can go through them for more details. Then in compatibility section, the following software tools allow you to program your board, both online and offline. You can program this board using Arduino IDE, IoT Cloud, Arduino CLI, the command line interface, and by using web editor. Then here, in compatible hardware section, these all shields and carrier boards are also supported. You can get further more information, quick start guides, tutorials, built-in examples, ideas for your next project, and DIY projects data from this page. Okay, alright, this is all about development board. Now let's move forward and see next important concept for this video. Now, let's see what is Arduino IoT Cloud in brief. So, the Arduino IoT Cloud is an online platform that makes it easy for you to create, deploy, and monitor IoT projects. It's like service of Arduino which provide all-in-one solution to build IoT-based project. As we know, in this IoT era, connected devices around the world are increasing by billions every year. You can find IoT devices everywhere around you in day-to-day life. You also must have known other similar kind of IoT service providers like Blink IoT Cloud, Google Cloud IoT Core, IBM Watson IoT Platform, Microsoft Azure IoT Central, Amazon AWS IoT Core, Particle IoT, etc. and so on. Arduino also launched their IoT Cloud services few years ago. So, in a nutshell, the Arduino IoT Cloud is a platform that allows anyone to create IoT projects with a user-friendly interface and an all-in-one solution for configuration, online editor for writing codes, uploading codes over the air, and also a dashboard for visualization of things. Let's see in detailed features of these Arduino's IoT Cloud services. So, first is data monitoring, means you can learn how to easily monitor your Arduino's sensor values through a dashboard. Then variable synchronization allows you to sync variables across devices, enabling communication between devices with minimal coding. Then next, the scheduler. You can schedule jobs to go on or off for a specific amount of time, like seconds, minutes, hours. Then next, OTA uploads means over-the-air uploads. You can upload code to devices which are not connected to your computer with cable. Next important feature is webhooks. You can integrate your project with another service, such as IFTTT. Then next is Amazon Alexa support, means you can make your project voice controlled with the Amazon Alexa integration. Then next, very interesting feature for makers, dashboard sharing. With this you can share your dashboard data with other peoples around the world. Awesome, right? So, how to get started with Arduino IoT Cloud? Let's see this with practical example of a simple DIY project, a basic thermostat control system, and its monitoring and control using Arduino IoT Cloud. Let's see the functional diagram of the project, which will show us how exactly this project will work. So, the thermostat system means it's a device intended to detect temperature changes for the purpose of maintaining the temperature of an enclosed area, essentially constant. Enclosed areas, like house, shop floor, server room, etc. So, we must require sensors to detect temperature and humidity changes, right? So here, we will use DHT22 sensor, which will be connected to Arduino MKR Wi-Fi 1010 development board. Here Arduino will act as a brain of this system. To maintain the temperature level, there should be a cooling device and heating device. Here, we will use two DC fans as actuators or load devices. These two fans will be driven by these two relays. We will use two-channel relay board, hence these two devices can be controlled by Arduino, as per programming. Here we will also use an OLED display to show the status of system and readings. These all blocks will form our main hardware unit. As its name implies, this Arduino MKR board is Wi-Fi enabled, hence we can connect it to any Wi-Fi router, which is further connected to the internet. Once this system get connected to internet, we will program it to connect it to Arduino IoT Cloud. So, once we got successfully connected to Arduino IoT Cloud, we can monitor and control this thermostat system from anywhere in the world, using any internet-enabled devices like smartphones, laptops or desktops. Okay, so in nutshell, Arduino will continuously sense the temperature and humidity using sensors, adjust the fan's operation as per programming, to maintain the thermal level of that enclosed area. It also displays system status on OLED display. Subsequently, it will send all the data to Arduino IoT Cloud via Wi-Fi and Internet. On other side, we can log into our IoT Cloud dashboard and can monitor, configure, and control the system. Here, the most important and fascinating thing is, once we registered our device to Arduino IoT Cloud, we can change its firmware, programming, scheduling, and automation over the air, wirelessly. Isn't it cool? Here we can also tweak with the system's settings from mobile application. We will see all these features in demo. So, this is all about functional block diagram of the project. Now, let's move over to the hardware section of this tutorial and see schematic or circuit diagram of the project. Here is the one. Let me give you brief description of all the connections. So, you can see, all wiring connections are in color coding and properly commented. Hence, you can easily track them. You will get this schematic on our GitHub page. Links will be shared in the video description. This is high-resolution image. You can zoom it further if you want for more detailing. Okay, so this was all about circuit diagram of the project. Now let's see how to create project in Arduino IoT Cloud. So, for that let's go to this website, cloud.arduino.cc. You will be visiting Arduino's official cloud website, this one. Here you can see this is a simplest, fastest, low-code way to get started with connected projects. In the pricing section, Arduino offers different plans for students, schools and professionals, as per their needs. Let's see. Click here to explore the plans. These are all plans. Here is the free plan, where you can create 2 things and unlimited dashboards. Other plans are paid versions. The features which we mentioned earlier, like OTA updates, dashboard sharing, APIs, and etc., comes in 2 premium plans. You can select those as per your need. In this project, we will use only free plan, so, students, don't worry. You can replicate this project even with your free plan. Alright, so let's get started. Click on this button for free plan. You will be redirected towards Arduino's login page. You need to sign in into your Arduino account with your username and password. If you do not have Arduino account yet, then you can just create new, all-in-one account. Here, you can also sign in with your Gmail, GitHub, FB or Apple account. Note that, this will be your main, all-in-one account, for Arduino Cloud, Arduino Online Code Editor, Arduino Store, and other Arduino services, so, we recommend to create new one. Okay, so we already have our free account, we will just sign in. Here, you can see, we have landed into Arduino Cloud homepage. You can find all the resources, documentation, these all guides about cloud, web editor, different IoT project templates, etc. You can access cloud apps from here on the top side of this page, or you can also go to this 9 dots icon. Okay, now let's go to our IoT dashboard. For that, you can click here. Alright, here new tab will get open, showing you the dashboard, which consists of your things, dashboards, devices, integrations, templates, etc. You can see, this is our previously created dashboard, about ESP8266. Then, you can also click here, if you want to create new thing. On this Devices tab, you can manage your devices. Add new devices, like our previous ones here. Node MCU ESP8266, Maker GSM board, etc. On Things tab, you will find things you created previously. Going into further. you will see on the Setup tab their associated cloud variables. Then hardware devices associated with this thing. And its network credentials, means, Wi-Fi SSID, and password, etc., since everything should have at least one device associated with it. Then down here, you can set the webhook. If you click on this button, Set Webhook window will get open. As they said here, webhooks allow you to send and receive automated messages to other services. If you are new to webhooks, you can check this sample project. You should enter a valid webhook URL for your thing. These all are supported domains, like IFTTT, Google APIs, Sheets or Maps, Zapier hooks, etc. You can enter your webhook URL here, and then click on Set Webhook to turn on webhook function. We will see this in our DIY project. Okay then, going back, next feature is, here is the Sketch tab, where you can generate the sketch, means, the code for your device associated with the thing. It will get opened in Arduino web editor. We will see that in a minute. And, next in Metadata tab, you will get details of your meta, like thing ID, time zone, etc. So, tags are metadata compassed by a key and a value. Assign tags to your things to organize and filter them. Each tag can be assigned only once per thing. Okay, then, these function, integrations, and APIs comes in premium plans. We will see about them in our next video. In the Templates tab, as they says here, import, use, and customize ready-made templates for your IoT projects. Here are the few templates, which you can directly import into your dashboard for learning purpose, like Cloud Blink, Cloud Energy Meter, Home Security Alarm, and so on. Down here, you can see, supported Arduino devices, and hardware is mentioned for each example, like Arduino Wi-Fi boards, Maker Wi-Fi 1010, Apple IoT Kit, etc. Let's see this Cloud Blink example in detail. Click on it to go into next page of information. Here, Cloud Blink means, you can control your Arduino board's built-in LED remotely through a dashboard in the Arduino Cloud. So you can see, here is the Import Template button, showing this project have, one thing, one variable and one dashboard. So, as notified here, this template will help configure your device, network credentials, and upload a basic sketch to your board. It will also generate a dashboard in which you can directly control the built-in LED. This is a great template if you want to get started with the Arduino Cloud. After you have completed the installation, you can modify the sketch and dashboard freely. Down here, they have given which development boards can run this template, like Nano 33 IoT, Nano RP2040 Connect, MKR Wi-Fi 1010, Nikla Vision and Portenta H7, etc. We are going to use Maker 1010 board, so now, I will just show you how this template get imported. Click here to import the template. So, here new window will get opened, prompting about, before importing. You will be guided through the setup of the device and the network you will use with this template. At the end of this process, a sketch will be uploaded to your device. Here click Next. Here it will prompt us about Arduino Create Agent not found. If you do not have already installed the agent, or if it is not running. So, what is Arduino Create Agent? It is the software which recognizes Arduino boards and other supported devices connected to your computer via USB. It is an agent between your hardware and online web editor. So, let's see how to install it. For that, click on this download button. It will download the program file in your Downloads folder. Let's go to Downloads. In Downloads folder, Here is the setup file. Let's install it. Install as per instructions given on screen. There will be one security warning about certification. Just click Yes to install the certificate. Allow any firewall access prompts if appears. When installation get complete, you will see gray icon in taskbar tray, like this, showing that agent is running and is ready to detect any Arduino boards you connect through USB ports of your computer. Let's connect our Arduino MKR Wi-Fi 1010 board. In Device Manager window, you can see it is getting populated in COM ports, like this. Alright, now return to your template import page. Here you can see our device will get detected. Please note that only Chrome and Firefox web browsers are supported by this Create agent, so it is recommended to use those only to get proper connection between your Arduino board and Cloud Console. In our case, this is showing an Arduino MKR Wi-Fi 1010 has been detected on COM15 port and ready to be get configured. So now you can click on Configure. You can name your device as per your choice. Then click Next. Here this will make your device IoT ready. Your Arduino MKR Wi-Fi 1010 will now be configured to communicate securely with the Arduino IoT Cloud. The process can take up to 5 minutes. Please do not unplug the device. Okay, in next window, you have to set your network parameters. You have to enter your credentials to allow your device to connect to the network. Let's enter SSID and password, and then click Next. Now the process of template components creation will get start. The Cloud Blink template is almost ready to be imported. We are creating all its components and uploading the sketch to your device. On next window this will prompt that Coder sketch has been uploaded to your device. And now you are getting connecting to cloud, and when you click on done, you will be redirected towards your dashboard, like this. And here you can see, you can toggle built-in LED of Arduino board using this switch, and its status also shown here. Let me show you the devices tab. Here, you can see our Make to Explore MKR 1010 device, and its status is online. Also it is showing that device is linked to thing named Cloud Blink. Okay, now let's see sketch and variables associated with this template project. For that, go to Things tab, and click on this Cloud Blink thing, which we have just imported. You can see Boolean variable named LED is automatically created. Our device is associated, and network credentials are listed. Next, when you move on to the Sketch tab, you will see sketch generated by the Arduino IoT Cloud thing, named Cloud Blink. You can also click on this Open Full Editor button to open this sketch into new window of full size editor, like this. This is web editor interface. Let's see its features in brief. Here, first you should select your correct board, like set here. Select both board and port if you want to upload a sketch. If you only select a board, you will be able just to compile, but not to upload your sketch. If you installed the Arduino Create agent successfully in last step, then your board and its port will get listed here. Here, with this button, you can create new sketch, create new folder, or import, like our offline Arduino IDE. This web editor also have examples, libraries, serial monitor, and other options. Here in libraries, you can search any library, or you can also import custom library if you want, but just remember that it should be in zip format. You can also go to Library Manager to explore or sort more according to boards or topics. Here, this is the compile button, and this is the upload button, which will get enabled when your board is connected to the correct COM port. With this 3 dots button, you can save, download, or share your sketch. This is tab button for adding new tabs, or importing any file into Sketch, like header files or secrets file, etc. And finally, this is your console log window, where you will see verbose of programming, compiling, uploading, etc. Okay, let's go back to our main editor window. Let's see the procedure of uploading code into any Arduino MCU board. Now let's upload the code into our Maker 1010 board. For that, first check our board is connected or not. Then check COM port number. Select that correct COM port. If it is not auto-populated, usually it will get auto-populated here in Web IDE. After that, make sure you have entered your Wi-Fi credentials, SSID and password correctly in the Secrets tab. Then you can click on Upload button to upload the code. During this process, you will get verbose of uploading and compiling in this log window. When code gets successfully uploaded, you can move over to your dashboard to see the demo. Check the LED toggle button is working. You can turn on or turn off built-in LED of Arduino board from IoT Cloud dashboard. Okay, so this was all about simple demo of Arduino IoT Cloud with ready-made template. Now, we will create another thing for our new project, Thermostat system. So, let's move over to the Things tab. Here, you can see, the Create button is disabled, because in a free plan, we can create only 2 things. Since we are opted in free plan, if we want to create another thing, we either need to upgrade, or delete one of these things. So, let's delete any one of these. Here is the Delete button, click on that. That will delete the selected thing. Now let's create new one for our project. Click here, on Create button, which will open another window. Here on this page, give proper meaningful name for your thing. Then next, associate a device for your thing. Click here, on this window, you can choose your previously used associated devices, or you can set up new device. So, we already connected and associated our Maker Wi-Fi 1010 board in previous demo. We will select that only. Okay, you can see, it get associated successfully. Now, let's configure the network. Click here, to open Network Configurator. Here enter your Wi-Fi SSID and password. This will connect your device to network. As they said here, you can also find these network parameters in the Secrets tab in your sketch, and your device will be able to connect to the network. Once the sketch will be uploaded, let me show you. For that, go to Sketch tab. Here, you can see, basic startup code is auto-generated. Open this sketch in Web Editor. Okay, here you can see, our project code is got saved in Sketchbook. And this is our Secrets tab, where our network credentials got saved. Okay, we will come back to Editor for coding, but for now, go back to IoT Cloud again to the Things tab. And in Setup, let's create some variables. So, variables are nothing but what you can monitor or control to make your thing function. For example, a temperature or a smart lamp. Once created, you can use them in your sketch. Click here on Add Variable, name it, like here, temperature. Then select its type, like given here, as a float. Then, select permissions. There are two types of variables. A read and write variable can work both as input and output. The data can be sent from the device to the cloud and vice versa. And second is a read-only variable. It can work only as output. The data can be sent only from the device to the cloud. In our case, temperature is read-only variable, since we are reading it from DHT sensor. Next setting is variable update policy, means how often it will get updated. Here also have two options, like on change, means the variable will be updated to the cloud whenever the change in value is greater than or equal to the set threshold. And another option is periodically, means the variable will be updated to the cloud each time when the number of seconds preset by user have been elapsed. Let's set it for 1 second, and then hit the Create button. Likewise, we will create different variables which we will require for this project. Just pay attention. To control the heating and cooling fans from Cloud Dashboard, we need to create Boolean variables. Note that space between variable names is not allowed. Then next, we will also send the status of our whole project system to the cloud as a message. For that, we will create string variable. Here, note that, in free plan of Arduino IoT Cloud, we can add only 5 variables. We need to upgrade plan if we want to add more variables. Therefore, to continue with the free plan, we will keep them as only 5. Okay, so you can see here in Sketch, our changes are populated automatically, and respective codes or subroutine loops are also got added. Alright, now we will create dashboard for our project. For that, go to Dashboards tab. You can see previously created dashboards are listed. Then click on Create button to create new dashboard for our thermostat system. Name it as per your choice. After that, you can see this is a canvas where you can add different widgets representing different parameters, data, and variables. Let's see. Click here to add the widgets. You can also search them. You can see different widgets like switch, push button, slider, and so on. So, we will first select gauge for temperature. Once you click on gauge, you will go to widgets setting by default. Give a meaningful name. Link it to correct variable. Then select gauge range. Then click on Done. You can change or edit its setting anytime by going here on these 3 dots option. Likewise, let's create other widgets required for our project, like percentage for humidity, switch for fans, etc. With these two buttons, you can toggle your view from edit mode to screen mode. With this button, you can go to arrange mode. Here you can change size of widgets and their location on canvas. Likewise, you can also lock their position. Then next click on Done. In the same way, here with this button, you can switch to Mobile View Editor to edit and adjust your mobile dashboard view, okay? Alright, now let's see the code of the project. But before that, let's see the algorithm. Here, we know that there are different kinds of thermostats and relevant systems, but in general, their main function is to read the temperature and switch the heating or cooling devices on or off depending on what the desired temperature is set to. We can use the DHT sensor to record temperature and then use this data to activate either a heater or a cooling fan to maintain the thermal profile. For example, let's say that we want to have a room temperature of between 20 and 25 degrees Celsius. Then, if it is below 19 degrees, we need to increase the temperature. So we will activate a heater. If it is over 26 degrees, we need to decrease the temperature. So we will activate a cooler. If it is between 20 and 25 degrees, we have a perfect temperature, so both the heater and cooler will be deactivated. This is the brief explanation to basic algorithm. Okay, now let's see the code. For that, head over to the Arduino web editor. Here is the code. Let's see that in brief. So, you can see, this code or sketch is generated by the Arduino IoT Cloud thing, thermostat system. These comments, variables, declarations, function prototypes, and subroutine loops will be auto-created during thing creation on Arduino IoT Cloud. So, you can see, there are three main source files which are important. First is main code file, where setup, loop functions, and most of the code is written. This one, which we are looking at right now. Then another important header file is thingproperties.h, the header file which we have included initially at the top of this main file. Let me show you, here, this one, so you can see that header file here, in this tab. Let's check this out. As they said here, this code is generated by Arduino IoT Cloud, do not edit. So, it is advised that we should not edit any of these variables, functions, subroutines, unless necessary. So, here you can see, these two library files, Arduino Cloud and Connection Handler, are very important for connecting our Arduino hardware to cloud. Here are the Wi-Fi credentials variables. These are things variables which we added in cloud. Then, their properties functions prototypes. Then next, these are properties of variables, which we set during addition of variables in the cloud, like read-write permissions, update policies, etc. And this is Wi-Fi connection handler. You must be thinking about from where this function will get these Wi-Fi credentials. That is SSID and password, so it will get them from another header file, which is secrets.h. Here is the one. We have done this earlier. If you remember, when we were associating our Arduino device in IoT Cloud, we've been asked to enter our Wi-Fi network credentials. Let me show you where. Here, in Things Setup, this is Network Setting, where we configured our Wi-Fi. These same facility will appear in Secrets tab. You can change these credentials from both places if you want. So, these three are important source files. Now let's go back to see our project's coding in main file. So here, at first, we have included all necessary libraries of interfaced peripherals, like for DHT and OLED display. All code is well commented. We have added detailed comments to each important code snippet, functions and subroutines. To guide you through these code implementations, we have added comments for each section of the program to easily understand for what purpose that code snippet is used there. Therefore, you can understand What's going on with these functions and variables? Let me show you the key point where we have implemented our thermostat algorithm. Inside the loop function, we will create 3 main conditionals. Each of these checks whether temperature is within a specific range and executes the code within the conditional statement. We have discussed these cases earlier in algorithm diagram explanation. Besides, if you have any doubts, questions or suggestions, or found any bugs in code, please feel free to contact us on WhatsApp or Telegram. All these source code will be available on project's GitHub repository on our GitHub page. We will share all the links in description. Okay, now let's see the demo of the project. First, log in into your Arduino Cloud account. Here is the link. Then go to IoT Cloud dashboard. It will get open in new window. In Arduino IoT Cloud, go to Things. Here is our project's thing, the thermostat system. You can see all the cloud variables. Associated device, MKR Wi-Fi 1010. Then in Network Settings, network is configured. Okay, now let's go to dashboard. Here is the dashboard with desktop view and mobile app view. Alright, now let's go to web editor and upload the code written for our project. Here is the code. We will keep dashboard open in another tab to monitor the thermostat parameters from IoT desktop. Now let's connect Arduino Maker board to laptop. You can see, when we connected it via USB cable, as soon as we plugged it in, it got detected here in web editor. It got listed with COM port. Now let's verify the code. Here the error is showing that we need to select the correct COM port. Let's select it, COM15. Click on Verify button. It will take some time to compile the code. Once compiled, you will see success message in console window. Then next, click on this arrow button, which is upload button to upload the code into your MCU board. Once code get uploaded, you can see OLED display will show some startup greeting messages. Then it will show temperature and humidity readings. On other hand, on IoT Cloud dashboard, you can see same temperature and humidity readings and status of thermostat system. Here, due to high temperature, cooler is activated. Heater is off. You can turn on heater manually from Cloud dashboard. You can see, temperature is greater than 26 degrees, hence cooler fan is activated, and red LED is showing high temperature status. On Cloud dashboard you will get temperature, humidity readings, then status messages, and here you can also manually override the automation to operate the heater fan or cooler fan. You can turn on or turn it off from here on dashboard. It will get reflected on hardware, since, as we learned, Cloud dashboard is digital twin of hardware assembly we connected to the cloud. Okay, so, in this way, we have seen brief overview of Arduino IoT Cloud. In this video, we have seen Arduino IoT Cloud free plan features. In upcoming videos, or part 2 of this tutorial, we will try to explore more features of Arduino IoT Cloud with Arduino Apple IoT Kit and the carrier board. All the important links are shared in the description. Stay tuned for more projects and tech updates. If you face any difficulty in replicating our DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@make2explore.com. We would be happy to help. Thank you.